But again, all of this stuff is reliant on your abilities to use the tools, right? So having the best computer with the most amount of memory and the most processor power doesn't mean it's going to work any better, or the results are going to be any better than someone who works efficiently on a smaller station, okay? They typically can do anything. It's just a matter of pushing them into that direction as gently as you can, okay? All right, so here is the fluid effect stuff, because I want you to get an understanding of what fluid effects is, because it's different than most of the stuff that we have already dealt with. So far we've dealt with rigid bodies. We've dealt with hard objects colliding with other hard objects and breaking apart or shattering them or moving or whatever. With fluid effects, we're dealing with containers, okay? So in a container, we basically have this box, and it's kind of like this just empty box. And one of the sucky things about Maya 2016 is that a fluid effect automatically comes with an emitter, okay? Now, it might be an option inside here to not add the emitter, which it is, but they used to have two options, one with an emitter and one without. You don't need the emitter for what we're going to be doing on our specific scene, okay? Because on our scene, what we're doing is we have an object. We have a sphere that we've animated, right? So on our building is standing there, the sphere comes in, or whatever object you created, and it hits the building and it explodes. So this is what you're going to be dealing with, is you have your building, you have your sphere, and it just comes in and crashes into the side of it. So in our application, what we're doing is we're adding fluid effects to that sphere, okay? So that's all we're doing in this specific file. So I'm going to add a 3D container. I'll uncheck that silly box, and that way I just get my emitter, or my container. Now I can move this wherever I want, but what I don't want to do is start to scale this out. As I scale it out, you can see these little panels on the bottom. That's basically my resolution of that box. And as I scale them, they're stretching out. We don't want them to stretch out, because then our fluid will be stretched out, okay? So what I need to do is inside my attribute editor, that's where I change my size. Oops. So if I make this 120 and then I rewind it, I just don't have enough to make them square yet. There we go. So I add more base resolution, then they'll actually be square. And then I would go this way and add some more here. So 30, there we go. And then height-wise, I would add some more, so 50. There we go. So I'm going to move this into position. And basically what I'm doing is I'm isolating where this effect is going to happen. Fluid effects are so intense, we have to isolate where the fluid effects are going to happen so they don't calculate all over the place, okay? So even further, like 160, that's good. All right. Now my ball starts way up here. Doesn't mean I need my fluid effect to start way up there. If my camera angle is only going to show it from here, then that's the only spot that I'm going to need to see it, okay? It's not a bad idea to do that just so you have more room. So 70 and 180. But the smaller you can make that, the more fit you can make that, the better off you're going to be resource-wise. Okay. So now this number here, the base resolution, is the resolution of the container, okay? So everyone knows what pixels are, right? They're a grid that go left and right and up and down. Well, these are voxels, and voxels are 3D pixels, meaning that they go up and down, left and right, but then they also go depth-wise. Okay, so it's basically a 3D grid of pixels. So when I hit play in here, nothing is going to happen because there's nothing emitting into this container. So if I grab the ball, shift-click the container, and say fluids, add or edit, emit from object, then that means that that sphere is now my emitter. Okay, so all of that fluid is then going to come off of that. So when I rewind this and hit play, now we can sort of see something. Yes, you can see it up there. You can sort of see something, and it looks pretty horrible, okay? But basically, each one of these little dots is a voxel, okay? It's one of those little areas that's just kind of filled in with fluid data. as I take this base resolution up, and I'm going to save my scene just so we don't do this again. Go. As I take my base resolution up and rewind it and hit play, you'll see that I get more detail inside each one of those because now I have more resolution happening. Okay? In order for you to get a good fluid solve, this number typically has to be up pretty high. All right? But that doesn't mean we need to start off pretty high. You can see how slow it's going at this point, how I just hit play, and it's going like super duper slow, okay? Now if I set this to 30 like it was, that goes pretty quick, but I don't get a good idea of what's actually happening with that cloud texture, okay? So this is where we have to be very gentle and maybe take it up to 60 and hit play and see if that's gonna be enough information for us to do what we need to do, okay? It's not until those last steps that we start to really crank this number up. And I've had this number up to 200 or 300 in order to get the detail that we need to get. Now just for fun, and hopefully mine won't crash, let's put it up to 300. You can see how dense that is, and we'll hit play, and you can see how slow this is going to go. You definitely don't want to work at 300, even though at some point you may be going up to 300. This is way too slow to work, okay? Now the other thing that you might notice is that even though I've gone up to 300, I still have this, which is these like blocks of where the ball is popping. Basically what's happening is my ball is moving too fast from this point to this point, and there's nothing in between to kind of blend that information in there, okay? For now, I'm leaving it, okay? At the very last stage of, well, not the very last stage, but pretty close to the last stage, we'll be tweaking that, okay? So I'm gonna go down to maybe 80. Let me see how fast 80 works. Okay, 80 is not too bad. I can live with 80. That's not terribly too slow. It gives me a good amount of detail to start playing with this setting. Okay. So now some important things. This fluid effect is bound. Okay, meaning that particles cannot go outside of that box. So when I hit play, you'll see that they are right here, and they're kind of wafting up very, very subtly. Okay, just so you can see this a little bit further, I'm going to go to my details and really take the buoyancy up. I'm going to really take the buoyancy up. 50. There it goes. Okay, so now you can see that those are now floating up towards the top. When it hits the top of the box, what is it doing? It's stopping and just kind of floating. So like a smoker's lounge, how the ceiling is all smoky, that's what it looks like. Okay, oops. Okay, because this is bound right here on the X, the Y, and the Z, that's what it's going to do, is that the particles just go up and they just kind of hang out. Now I could take the Y and say there is no boundary. Now what that means is that it's just going to disappear. Okay, now in some instances that's acceptable, because if we're angled a certain way and we don't see that the particles are just disappearing, that's fine, and they actually like save us some render time. In some cases you want a boundary, in some cases you want wrapping. So wrapping, watch the bottom. There it comes up from the bottom. Okay, so in some cases you may want to play with those. For what we're doing, I'm most likely not going to want to have any boundaries on this, because what I don't want to happen is that as my meteor is kind of flying through, I have this flat area of smoke kind of sitting up at the top. Okay, now you can get away with that just by adjusting your settings and not needing any boundaries, and just by containing it. If I didn't set my buoyancy, which is kind of like the floatiness of it or the anti-gravity of it, I wouldn't have to worry about any of that. Okay, so I'm just going to set this back to 1, which was the default, I believe. Yes, sir.
Is there, you know how like there's when you crash in something, there's like this giant wave that just spreads out?
Like,
It's like, say this is crashing into it, and then like some, like
Shockwave?
it's yeah, basically like a shockwave.
right. You could animate that and simulate it, but that would just be a separate thing. Okay. With fluid effects, we focus on kind of like one thing. Okay. In this specific instance, I'm focusing on the smoke trail that would follow this. But if this was a meteor, there might be chunks of debris also flying off. That would be another simulation that I might do. And then when it hits the building and there's a bunch of smoke there, that would be another simulation I would do. Okay? So when they do this kind of stuff, they actually have like multiple simulations stacked on top of each other in order to create that final look. All right? Does that make sense? All right. So that's what the boundaries are going to do. This next area is the content method. And basically, it's what is making this particle or what is making this fluid do what it's doing. Okay? So right now it has density and it has velocity. They're both put on dynamic grid. Dynamic grid, dynamic grid. Temperature is off and fuel is off. So basically this is just kind of like smoke. Okay? Think of this like an actual, like a gas fire, an oil fire or something. If you have oil or gas and it's on fire, it gets really, really hot. But then what happens as it loses heat?
It rises.
It rises, right? It turns into smoke. So we have gas starts on fire, turns into smoke. The smoke is obviously not as hot as the fire, and it turns black or gray or whatever, and it goes away. So that's how we would think of this. In this case, we're just dealing with smoke. But if I wanted something that has a flame to it, I wanted something hot on top of it, I'm going to turn on my temperature and I'm going to turn on my fuel. Okay? So now when I play it, we get pretty much the same result. There's not really a big difference in what I just did. Okay? This just allows these options to be activated. Okay? That's one of the suckiest things about fluid effects is that we change stuff, we hit play, and then things just don't work because sometimes these things are kind of linked together in order for us to see that. Yes, sir?
How does it know to stop the smoke when it's doing?
When it does what? It doesn't stop. It does it. Oh, it does because, there we go, it's going outside. Okay, so once that sphere jumps outside the box, then that's something we'd have to deal with. Now, let's say we don't realize that until the very end. We can always jump back up here and start to change these sizes again, okay, and make that a little bit bigger. All right, so now we have dynamic grid for all of these. Now, we have two items that we're dealing with. One is this cage. One is this particle cage that we're looking at. The other one is the emitter. And the emitter is giving us density and heat and fuel, okay? So if we wanted more heat or more fuel or more density, we could come in here and populate this with more stuff. So I could say I want the density to be 10 times as much density. And I would have 10 times as much density, okay? Or if I wanted more fuel, I could add more fuel. Now again, nothing's gonna really change because I haven't set anything up to change. Okay. So then I'm going to come down to some of these other methods. Okay, there's a lot of stuff inside here that I'm just going to kind of skip over. The display is kind of a neat one if you get more into it, but for right now we're good. Voxel quality, it's typically you want to go better with this. Okay, but again, these are things we can always change after the fact. It's not anything we have to change right away. And if you look at it, you'll see that there's not a huge difference in speed or quality that we're looking at. We can also look at velocity draw, which is a somewhat neat one where you can actually see what's moving inside here and you can see where these are going. So these specific voxels are moving up gradually. Okay. The ones way down the bottom, they're still there. It's hard to see. They're still there, but they're barely moving. All right. So that's just other stuff that, you know, gradually get into it. Dynamic simulation is the next area we're going to play with. Okay. So a couple terms that we're already familiar with is gravity. We already know what gravity means. That's just the force that's pulling something down. If we turn gravity off, that's going to lessen the effect of gravity, obviously, and it may push the stuff up a little bit further. In this case, we're not seeing a huge difference. Viscosity is a new term. Viscosity is basically the object's thickness, right? That's how you can look at it. A thicker object is going to have more viscosity. So something like maple syrup or yogurt is going to be a very thick viscous fluid, where something like water is going to be a less viscous fluid. Okay, so for smoke we can kind of ignore that, but if we wanted things to kind of stick together or hold together a little bit tighter, we could start to increase this value. Okay, friction is the friction between the objects. Okay, we don't need to worry about that too much. Damping you should always worry about. Damping is the natural ability for an object to start to slow down. So as an object starts moving, it needs to have some sort of damping applied to it to help it slow down and come to rest. At 0, it's basically just going to continuously move forever. Okay, now again, you're not going to see these things happen right away. It's stuff that as you start adjusting things, you may need to jump in there and start tweaking it. That's why as you work, you kind of hit the highlights and then come back and hit some other spots and then come back and hit some other spots. This is the kind of solver it is. I just leave that defaulted. The high detail solve I do as all grids. Okay, so high detail solve I set to all grids because what it's doing is it's doing a more accurate solve all over this entire grid, all over the entire settings of this entire fluid container. Okay, solver quality is set to 20. These settings here are controlling the amount of dynamic calculations done to it. Okay, so for now we can leave it at 20. It's good enough. Now this is actually going a bit slow for me. You can see it's just kind of like the smoke comes out and it just stays there. So the only way for me to make it go faster, I could go back to the buoyancy and I could up the buoyancy, and that would make it obviously go quicker. But one thing I can do is take this simulation rate scale and pull that up. And what it's going to do is it's going to make this simulation act 5 times faster. So however slow it was moving, I can speed it up inside there. So now it's going 5 times faster than it was. Or it's going 3 times faster than it was. Okay? So I can play with that to get different effects, different things to happen as far as how fast this is moving. If I see that's moving too slow or too quick or whatever, I can come in and tweak those settings. All right. These are just some settings that we can look at later. Liquids we don't need to worry about. Auto-Resize is a neat one. We have this container going around our entire area. With Auto-Resize, it automatically draws the box wherever the object is. So as I hit play, you can see that it's automatically going to follow my shape around. It's thinking.
And down it goes.
Yep.
There's a video card. I just
Yes,
saw
it
the
was.
video.
All right. So that's what Auto-Resize is going to do. And what's kind of cool about it is that it, automatically resizes. The problem though is that once it starts getting too big, it just, doesn't stop. It just keeps going and going and going. Where with the container, we can basically contain that shape, so it doesn't kind of go crazy and go on forever. Okay. There's also this resolution. So this resolution up here, we don't need to really worry about too much because we have this resolution. Okay, so we can up that resolution to increase the kind of particles that we have. So I'm just going to turn that off for now. The other area I want to play with is the content details. This is where a lot of the look of our particles is really going to come into what it's doing. So we have density, we have velocity, we have turbulence, we have temperature, we have fuel, and we have color. Okay, so density is the first one. This fluid has density, it has thickness to it. And right now that's all we're looking at is density. We're just looking at the thickness of this smoke cloud. So we can take this density up or take it down to create different looks. Now for some things density is going to be enough. Think of like a cigarette smoke. All you have is this little smoky trail. That's typically going to be enough. But sometimes we're going to need stuff like temperature and fuel for the other stuff. All right. So we can look at this a little bit more in a second. I'm going to go down to velocity, and I'm going to add a little bit of swirl into this and a little bit of noise. So what this will do is actually give our smoke a little bit more movement. Before it was pretty stagnant, wasn't doing a whole lot of stuff. Swirl will actually give this kind of like a spinning effect. And noise will just kind of break up some of that static movement so it doesn't look so boring. I'm going to add a little bit of turbulence in here as well. Okay? And again, my numbers are for my scene. You have to look at your own individual scene and play with the settings in order to get them. You can see what this did being at 1, 1, and 1, the swirl, the noise, and the turbulence, that I need to go through and start to play with these to get them a little bit more honed into this specific scene. Okay? So that's maybe a little bit too much. 0.15.
Is there a way to change the color?
Yes, that's what we have to do next. Okay? In order for us to play with temperature and see temperature do anything, we have to adjust the color, because that's really where the temperature kind of shines. So under shading, this is where all of this is going to happen. So we have transparency, which is no big deal. I'm sure you're familiar with transparency. There's color. And right now my color is just a constant white color, and that's why it looks kind of horrible. So I'm going to click on this. Each one of these things is a ramp, so a gradient from one side to the other. So I'm going to click on it and change the color to black. And you'll see the second I change my color to the middle to black, we now get something that looks more like a smoke trail. Okay? It looks more like something really hot by that sphere and gradually changing color. Now what's happening here is that this color is being used on top of this incandescence. Okay? So where it's white, it's going to be white. Where it's black, it's going to be this. Okay? That's where it's getting that information from. Now I can slide this, oops, not this. I can slide this down here, slide this way. There we go. And I can get different effects with this, but it's just using the one color right now. It's just using this far right color. I'm going to change this to density. Okay? Now when I change that to density, what it's doing is it's using the density as something to color it. So think of the most dense areas of this object being white. The most thinnest areas, the least dense of these objects, of this fluid, being black. Okay? That's what this is showing us. Most dense is white, least dense is black. As I pull the black up here, you can see how I'm influencing a little bit more of that. Okay? Now I could also take this input bias and change that as well. I'm actually going to take this white and just make it like a gray. And I actually said that backwards. This is the least dense. This is the most dense. Okay. So as I take this input bias, I'm pushing the information one way or another way. Okay. So what this allows me to do is control where this slider is, where this information is coming from. All right. So then I can come down here, and this is going to work in a similar fashion, but this is working off of temperature. Okay, so again, the hottest areas are going to get one temperature, or are going to get one color. The coldest areas are going to get another color. Okay, so if I go in here and I look at this yellow, and I start to pull these back a little bit, there we go. You can see how I can get some nice little yellow touches of color right inside there. And as I play with this, this is essentially doing what this does. So as I slide these things along, it's doing a similar type thing, but it allows me to keep my colors basically where they are and just slide this one slider to control where that value is coming from. Maybe I'll take this and add a little bit. And maybe I'll add a little bit of red in here. There we go. Okay. So now this is using the temperature. So now if I go up to temperature and I start to play with the temperature scale, you can see how now this is affecting it. Before, we weren't using the temperature at all. We were just getting color information from that original object, just from the original stuff. Now that we've switched this to be using density and given this a gradient, that gives us access to incandescence. And now incandescence is using temperature. Now I could use this as temperature also. Subtle effect, but it's still there. Okay. So then I could start to play with this. I could say, okay, well, my temperature is going to have some noise to it. Okay, and a little bit of tension. Okay, and you'll see that that temperature now is kind of flickering a little bit because it has that noise inside there. It's not a constant temperature that goes here or stays in one value and then just disappears. What happens is it flickers a little bit. Okay, so imagine at the very beginning of this, we have particles being emitted. Those emitted particles are coming out as one temperature, and it's very, very hot, okay? And it's very, very dense because it's right at the beginning. So those particles are going to be this far right color. They're going to be as close to this as they can. Because I slid it over, it's going to be like right there. Now they're also in this density area here, so it's using that color information. This is not really used too much. It's very subtle, okay? As they start to be around, their temperature is going to start to dissipate. The temperature is going to gradually go down, okay? The density is also going to go down. That's what's happening at the edges of this. Temperature goes down, and then it starts to see just the density. And the density goes down, and then that goes away. Oops. Okay? And here's where I can take my dissipation of the temperature. And if I turn this off, and turn diffusion off, we should get something that stays a pretty much constant temperature. Okay? Or it stays on for a lot longer. Okay? So this temperature is now staying there a lot longer because I haven't told the temperature to start to go away. That's what dissipation and diffusion do. I prefer to use dissipation over diffusion. Diffusion is kind of like a Gaussian blur where it just kind of like softens it overall. Dissipation is actually like kind of randomly picking what starts to go away. Okay, and then I can play with this temperature scale to control how much of the temperature is there. You can see as I pull this up, I'm starting to get some of those red values that I wasn't picking up before. Okay, and as I start to pull this back down, I'm smashing all the other values that are inside there. Okay. There's also pressure, and this is kind of a fun one to play with. If I go to my density pressure and put that to 1, and I put my other 1 to 1, so you get this like weird effect. Okay. Obviously, some of these are meant to be very subtle, and some of these are meant to be a little bit more aggressive. It's actually pushing it in the same direction that the object's going. So the object's going this way, so there's a lot of pressure behind it pushing it that way. All right. Now, one thing I'm going to do is make this a little bit bigger. So like we said before, this is kind of like sticking out. Let's push this a little bit that way. Let's make the width a little bit more, so maybe 50. Okay. So now I'm starting to get to the point where this is, getting the look that I want. Now what I'd like to have happen here is that when it hits the building, it emits a lot more. Like there's a big explosion type thing that happens. So what I can do is go back to my emitter, and I could have it emit a whole bunch of particles right at that point. So right here, let me rewind it and just go forward. Right about there, I'm going to set a key. I'm going to go up a couple frames, set another key for like 1255. I should save it, thank you. And then I'm going to go up a couple more frames and then set this to be 0. Okay, we'll save again. No, what should happen is that it hits it, we get that big explosion, boom, there it is. And then it gradually goes away. Now this is again stuff that we have to play with, because right now you can see it's like a smoke bomb in the middle of nowhere just doing nothing. Okay? Oops. So I can also go into my fluid shape and start to play with some of these other settings. I can start to play with the dissipation. So I could say, okay, well, after it hits right about there, then I want this to really start to dissipate. Okay, so I'm going to keyframe that dissipation. I'm going to keyframe that dissipation. Go up a couple frames, and then just set these to maybe 2. And this is where we really have to get into it and start playing, because, you know, what is a good value? We don't know until we put it in there and try it. That was too much. Let's just scoot those over a little bit. Remember when I said that it can crash? And here we are again.
Yeah, that's why I have radio in. I don't like NVIDIA.
Yeah. Well, I can use this all day. I'm going to go to my fluids. Sorry, not my fluids. I'm going to go to my end cache and go to create new cache, Maya fluid. And here's where we could set this up. Let me make sure my project is set. Yes, it did. There we go. What's that? There we go. Okay. So here's where my fluid name is. It's going to create 1 file per frame, and it's going to use the entire time slider as my cache. So if my cache goes past 120 to, let's say, 200 or 400 or whatever, I definitely want to specify that. This evaluate every frame. Right now, remember at the beginning we were getting these like circles happening? Okay, right now it's not too apparent because they're blending in nicely, but before we had like a circle, circle, circle. This is where we can take this evaluate and lower it down. So what's happening is we have this frame and no information between them. Evaluate every 0.25 frames would create subframes, and it would evaluate what's supposed to be happening inside those frames. So I'm going to click this just so you can see what's going to happen. I'm going to, of course, save first, and then click create. And you'll see that this is going to go basically every 0.25 frames down here and figure out what my particles are supposed to be doing, what my fluid is supposed to be doing. Okay? And as it does that, what's happening is it's writing that information out to the hard drive, out to your drive, wherever you have this set. So if we go into the P drive, if we go into where I've saved this, and I go into my cache, fluid, chatter, there it is. Okay? So right here, this is my very first frame. Okay? And gradually, we're getting more and more stuff inside here. So you can see that for each one of these frames, like that, I believe that's all one frame, we have these 8 megabyte files. Okay? That's all the information. Basically, everything that it needs to look exactly like that for every frame is written out to the hard drive. So this is where your folder is now going to start to take this huge hit on file sizes. Okay, my computer last night when I was doing my stuff went from having 60 gigs free to having 40 gigs free because it was saving so much information to the computer. Okay, in order for it to cache out my simulation. So now imagine that you went even less on this. I can't see it because it's doing it, but even less on those steps. Instead of doing 0.25, you did 0.1 or you did 0.05. That's a lot more information being written out to the hard drive. Now imagine you have 500 frames instead of 120. Again, a lot more information is getting written out. I had someone last year ago, 2 years ago, whenever, they had 80 gigs of stuff that was written out to the hard drive, so that when they left at the end of the night, they had to back all of that up. Otherwise, they have to re-cache out everything. And then when they come in the next day, recopy all that information so they can work off the stuff. At that point, it makes more sense just to get a portable drive and work off the portable drive. Okay? So now, this is, like I said, just what it looks like as far as movement goes. All of this red and yellow and black stuff that's there, that's all stuff that we can change after the fact. I can go into this and modify what that's still going to look like. So just for fun, I'm going to wait until it gets to about 45, and I'm going to hit escape. And that should stop it. Actually, it should go pretty quick after that because I've dissipated it, and it should go away. Yes. If you hit escape, see on the bottom here, press the escape key to cancel. Now that will still save all the information up to that point. Okay? Again, remember in RealFlow, when we hit simulate, it automatically caches everything, which is cool. In here, we have to tell it we're caching. Write this information out. So obviously, when we cache something, it's more locked in. All right? Now, if I wanted to make changes to the way it's moving after this, if I realize, hey, I want the ball to explode 2 seconds later, or 2 frames later, or 2 frames earlier, we have to go back and delete the cache and make a new cache. Okay? All right, that looks pretty cool the way that is. All right. Now, also, the building itself is not interacting with my cloud. Okay? So the smoke is just a big smoke cloud, and my building pieces are just kind of like peppered inside of it. I could have the building pieces collide with these pieces, and that would give it a little bit more interactivity to it. I'm going to hit escape because this is taking longer. Grabbing the building here, oops, there. Grabbing my particle cloud, going to fluids, I could say right here, make collide, and those two things would collide. Again, just takes more time as we do stuff. And I believe, yes, we just have that tessellation factor. This is basically, you know how we had the collision shape? That's what that is. It's basically setting a resolution for each piece. The higher this number is, the more detailed it is. For something like this, it's not going to matter too much. 200 is a fine number. Okay? So now that this is cached, I should be able to just click and drag and see this in real time. Okay? Or whatever, as I'm scrubbing. It's probably not going to play back real time just because it just doesn't have the resources to play it back in real time. But now what I can do is once this is set up, then I can go into my shading and I can still adjust my transparency. I can still adjust this density. I can still adjust this temperature, okay? Because I'm just controlling the look of it. Now if I went into one of these settings, content details, density, there it is, and I started to adjust buoyancy, that's not going to have any effect on it because buoyancy is dynamic. It's something that's calculated at dynamic simulation time. Density scale, however, is calculated when we do the shading because it's literally just scaling it up or scaling it down. It's not dynamic at all. Okay? The rest of these are dynamic. I wish that that was somewhere else, but it's not. Same thing with temperature scale. I can control the temperature scale right here without having to recache it. If I wanted to recache it, I go back to my cache and I would say either disable all caches or just delete the cache. Okay, now the cache is gone, so then I could go through and say, well, I'm going to add in that collision. There we go. And then I'm going to recache it. So I grab that again. I go back to my fluid effect, and I go to that. Okay. Now you'll see, even though I said delete cache, I get this error message or warning popping up saying that you have one that already exists. Even though I checked delete the cache, all it does is disconnect it. It doesn't actually delete it. So even if you've deleted it, it's still in your folder taking up space. So if you do want it gone, make sure you get it gone. Okay? You'll find as you do more work in dynamics that you're going through your drive and you're searching for stuff like .pdc files, which is particle disk caches, which is essentially the same thing. Or you're looking for, I can't think of the one. P drive. I'm trying to think of the actual extension that this one uses. Workspace cache. MCX, okay? So you're also looking for MCX files because those can just eat up your hard drive space and you not really know it because you just assume that mine knows what it's doing. Okay? So here it comes in again. We're going to see it collide with it. Maybe it'll do something cool, maybe not. We'll see. Actually, let's just hit escape. Okay, you get the idea with the cache. It just saves it. Wonderful. Delete the cache. I just want to see what it's going to do when it collides with it. There we go. All right, so that adds a kind of cool effect to it. On top of the effect that we already had. So again, you have to play with the stuff. You have to kind of look at it from several angles just to kind of see what you're going to be doing with it. Okay, and this is something, like I said, you'd set this maybe not 2000 to maybe 200, save it, and then do a cache, let it save overnight. Okay, and then let it see what happens in the morning. If you do that, obviously you need to make sure that you have plenty of hard drive space. We have 180 gigs on these computers. Obviously, you do several caches, several projects you haven't cleaned up, that could eat away a bunch of space, okay? What has happened to me is that I've set it to go, and I wake up in the morning, and like an hour after I set it, it says you run out of hard drive space, and it just stops, okay? And literally like megabytes is what I have left in my hard drive space. So you have to make sure you have enough space in order for all that stuff to function correctly. Okay, so in a nutshell, that's what the dynamic fluid effects are and how we can play with them. There are some other settings like under shading quality where we could crank the shading quality up and make that a little bit nicer. Under textures, there are some spots where we can actually texture the color and incandescence and the opacity. Opacity we didn't get to, but this is essentially the same kind of thing as the other ones. Oops, I set that to 200 still. But with opacity, there it is. We have this graph and we can control different areas of different opacities. So maybe right at the beginning, we have it becoming very opaque. And then right at the end, we have it kind of getting a little bit more transparent. Okay, so we can play with these in order to get different effects so that the opacity is not simply this smooth gradient that goes from black to white or transparent to opaque or vice versa, but it actually kind of trickles off into these different patterns. This is where if you were doing fire, where you would get a lot of that effect of the fire and getting the little fingers of fire that kind of flare out. Shading opacity, texturing this stuff, good. Also lighting, you can tell it's the self shadow, which is not really going to see anything, but the shadows would be on top of there once you do your other rendering. Okay, so essentially that's fluid effects. You can watch a video that's up on the canvas. I'm going to